again, good morning to all. Good evening to all. So here, I'm just starting the DevOps demo session here. So first of all, what is meant by DevOps? Okay, so DevOps is nothing but it is a methodology. It is a process. So in which both uh, the activities done by the developers and operation team. So actually, in the previous, the both that whatever the activities that are done by the developers and the operations team. So there is no communication between these two channels, that is the developers team as well as operations team. So DevOps is the methodology which is coming to picture, which reduces the gap between the both developers and the operations. That means DevOps is a word that is coming from the developers and operations. That means DevOps engineers, so they can perform except the operations that are performed by the developers. So the function of developers is to write the code. That's it. The function of developers is to write the code. Just a minute. So the function of developers is to write the code. So they can write the code in any language. Generally, so there Java developers are there, so .NET developers are there, and some other languages. So recently Python also there. So whatever the language, the developers which are writing the code, so they are putting this source code in the one repository. That is called one storage hub. That is called repository. The task of developers ending with this. That is, they are writing the code and pushing the code into the repository. That is the end of the developer's task. So from that, after that, DevOps work will start. So here, actually, in most of the companies, so they are following the SDLC. I think all of you know about the SDLC, Software Development Lifecycle. So it is having so many phases. So starting from, so when the customer required some project, okay, so just he bring the project to the company, particular company. So then, so once the company has received the project requirements from the customer, so they are doing the planning. So they are doing the planning first. So then that project, so depending on the size of the project, that project maybe it is divided into some small number of chunks. So that small number of chunks are allocated to the developers, and each and every developer working on so and so module. For example, let us take any e-commerce website like Amazon. Amazon website is there. Let us take. So Amazon website, it is a combination of so many services. Like, so for mobiles we have one section is there, for TVs we have one section is there, for clothes we have one section is there. Likewise, for electronics we have, like that we have different sections are there, and after all these are subsections. Along with these subsections, we have the most important, the cart section is there, and billing section is there. So all these sections are called as services, and these services are called microservices. So in the olden days, what happened is, so the entire application is a single package. Entire application is a single package. That means all these services, whatever all the services which are under a single package. So but we have some drawbacks of this having a single package. So what is the drawback means? It is a large size. The first and foremost is it is a large size. For example, if there is any issue, okay, the first point is it is large in size. because as the number of services which are adding together, then the size of the application will be increased. Size of the application will be increased. That is the first point. Second one is, so if any one of the service is down, for example, some TV section is go down. So what happened? The entire application is go down. Entire application is go down. If even though there is this issue in any one of the service, so entire application is go down. And one more point. For example, if most of the customers are interested on so and so part, so say some, let us take some mobiles. So most of the customers are so they are doing the working on these mobiles. They are purchasing on mobile section. So what happened? Automatically, the remaining services also will be overloaded because all these services are in a single package. So that's why, even though the customers are engaging in this mobile purchase, so the other services also go down. So these are the major drawbacks of having different services in a single package. So to overcome these drawbacks, so we have a topic called microservices. So microservices means, so for mobile, so there is a separate service. For TVs, there is a separate service. For clothes, there is a separate service. All these services are added up together to form a major application. The main advantage of this microservices is there is no down, application down. The application is running continuously. For example, if there is an issue in any one of the service, so then what happened? Only that particular issue can be resolved. So there is no issue with other services like TVs, clothes, or electronics part, or any other services. So all are working fine. Remaining services are not overloaded or working fine. If it is very easily identified where the problem is exactly. So that is the advantage of microservices. So today most of the companies are adopting these microservices technologies rather than working the entire application as a single package. So this is a major basics to understand. So what is microservices, and this collection of all services in a single package, that is called monolithic application. That word is called monolithic service. We can call monolithic service. So maybe in interview point of view, they may be asked, so what is the difference between monolithic service and microservice? This may be the first important interview question that I'm saying here. That is monolithic service and microservice. Monolithic service means it is a collection of all services. Collection of all services in a single package. Whereas microservices means it is also collection of individual services which are working independently. So there is no dependency. So mobile application is different. So TV application, TV service is different. So there is no dependence between mobile and TV. So that's why there is more reliability will be there, more transparency will be there. If any issue is there, it is very easy to solve in the microservices. Not going for monolithic. And if any issue in any one of the service, the entire application is go down with the monolithic service. Whereas this is microservices are, there is very less chances of application go down. So this is the main point. So most of the industries which are following the microservices recent nowadays. Coming to the DevOps topic. So DevOps is nothing but it is a methodology which reduces the gap between the developers and operations team. Developers simply they are writing the code in any one of the language, say Java, .NET, Python. So and they are simply pushing the code into the repository. Okay, so for example, let us take Java. Let us take a Java language because most of the industries are working on the Java language only. So applications are designed mostly on the Java-based languages. So here Based on this Java language, so there are three types of Java languages. Majorly three types of Java languages, that is versions, we can call them as a versions. The first one is J2 SE. Second one J2 E. Third one J2 ME. So what is J2 SE? So J2 SE means it is Java 2 standard edition. Standard edition. Here it is Java 2 enterprise edition. And third one is Java 2 micro or mobile edition. Okay, so means in the Java itself there are three types of versions are there. So Java 2 standard edition, Java 2 enterprise edition, so Java 2 mobile edition or micro edition. So this Java 2, all these are languages only. Okay, I'm just putting I'm giving the inputs on only the language itself. So first in the basics of Java 2 in this edition, so only a few services are there. Since it is a standard edition, in standard edition only we have some only basic functions are there here. Here we have only some basic functionalities will be there here, like JDBC, Java to database connectivity. Only few features and few functionalities which are there in the standard edition. And coming to this enterprise edition, so here we have uh, the coding that is having multiple applications like servlets and JSPs and EJBs. And third one, micro edition or mobile edition. So here the developers which are writing the code which are related to mobile version, nothing but apps. For apps point of view, they are writing the code. So as a DevOps engineer, you are no need to learn any coding language. There is no need to learn any coding language. The coding will be done by the complete developers itself. See, the process of DevOps I will explain now. So here, first developers will develop the code. So that code is in ASCII format. That code is in ASCII format. But that code is not understood by the computer, that is laptop, because laptop can understand only the binary format. So I think most of you never have this one. So whatever the code that is developed by the developers, that is in the ASCII format. So that means the DevOps developers role will be end up to this part. So they are simply writing the code in the ASCII format and then pushing the code in the repository. From this from after this coding section, our role will start. So what are our roles? What are the DevOps roles? So after the coding done by the developers, then because ASCII is not understood by the machine, so we need to compile the code. We need to compile the code. Whenever you do the compilation, so what happened? This ASCII language can be converted into bytecode. This ASCII language can be converted into bytecode. So this bytecode can be understood by the machine. I think as I said before, computer can understand only zeros and ones. Means binary language. So binary language means again bytecode. It is nothing but byte. Byte means 8 bits. You know that. 1 byte is nothing but 8 bits. Okay, so that means the computer can understand only the binary language. So therefore, when you do the compilation, then what happened? The ASCII code can be converted into the byte code. So after this byte code, so that is after this compilation, so we need to do the testing. We need to do the testing. So that means if the code is perfectly written, any errors are there, any bugs are there, so that should be given. That is test reports that should be prepared. So as a DevOps engineer, we are no need to prepare the test reports. For the testing team will be there. Testing team will give the test reports. Also, developers also will give the test reports. Okay, so I'll explain this part again. Okay, so I'm explaining the phases now. So first one is coding phase, next one is compiling, next one is testing, and next one. So if there is no errors in the code, if there are no errors in the bytecode, then we need to package. We need to package the entire code into a single file that is called artifact. That is called artifact. That single package is called artifact, or that is also called as application. So to understand more clearly about this one, so in our Windows, for example, if you want to install some say VLC player, so what you need to do, you are simply downloading the file from the website. So what is the type of that file? What is the type of that file that is downloading from website? That is .exe format. .exe format. That is, you are downloading a single file. So this VLC media player, that is also an application that is also developed by some developers in different languages. But finally, what we are doing? So we are downloading a single application with .exe, that is executable file. So when you double click this .exe file, then what happened? So many stuff that is happening in the background. That means it is extracting first, then it is executing. When you click on next, 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 and finish, so what happened? Internally, it is extracting all the files. It is extracting all the files that are packed. So it will execute all the files, and finally, when you click finish, so VLC player is start running. That means you are not downloading all the files. You are downloading a single file. That is .exe file. That is collection of so many files. If it is a Java language, so that Java finally it is nothing but .jar file. Java file is ending with .jar. So this .jar nothing but .exe in Windows. How we are downloading the executable file for a software for an application. So similarly for Java file, we have an extension called .jar. Okay, so next after completion of this package, that is a single package that is called as artifact. So then now the application is ready in one format, or like .jar format. The application is now ready. But we need to put this application, that is ultimately the customer requirement is to run the application. Ultimately the customer requirement is to run the application. So now the application is ready, but where you need to put this application to run, to make it to run. So the application that is make it to run, that is called runtime environment. That is called as runtime environment. So runtime environment. So now nothing but this is one environment. Now the package is ready. You need to move this package from your local to this runtime environment. So this process. So what is the process? The process of moving this package into a runtime environment is called deployment. So this is the main role of DevOps engineer. So every day you are going to see some deployments. That means every day you are the main objective of DevOps role. DevOps is to do the deployments. So what is meant by deployment? Deployment is nothing but so moving the package into a runtime environment. That is called deployment. So now the deployment is done. So deployment is done. So that is the application is running. The application is running. Next, what is happening? So now customers will access the applications. Let us take in earlier example. Let us take Amazon. So that is a website that is developed by some developers, and finally we are deploying. And now the application is ready. Customers are now accessing the applications. So now, if there any maintenance, that is service, we need to provide at the end. So that is called delivery. That is called as delivery. That means that application should reach to the customer without any bugs, without any zero downtime. The application should run continuously. The application should run continuously without zero downtime. The customer should satisfy so with that application. So this is the flow that is happening in most of the software industries. That is, first one is code. Code means the developers which are preparing the code or developing the code in ASCII format. So next, this is a part of only developers. All these tasks are by DevOps engineer only. So previously, so different environments, different team in most of the companies, different teams will be there. So there is no communication between those two teams except in the peak times. But nowadays, only this developer can develop the code, and the rest of the part that is done by the DevOps engineer only. So that's why it is just a communication between the developer and our DevOps engineer. That's why it is the name as DevOps. So now, as I said previously, so code is prepared in the ASCII format, and this code uh, uh, it is not understood by the computer. So we are converting the code into bytecode by doing the compilation. Later, that bytecode can be understood by the system. Now we are doing the testing, that is test reports. Generally, these test reports are given by the developers. So developers will give. So while writing the code itself, they are doing the testing. Developers while writing the code, so they are doing the testing. The testing is called unit testing. The testing is called unit testing. So, and testers will be there. And testing team will be there. The testing team will do the integration testing, and they will give the test reports. So all the test reports will be placed here. So if all the test reports uh, should give zero errors, zero bugs, zero duplicates, zero code vulnerabilities. So if all tests are passed, then only we are allowing to do the package. For example, if you are doing the package with some errors, so what happened? You are doing the package. So even though some small errors will be there, some small warnings will be there, but you are doing the package itself. So what happened then? So then there is no guarantee to that software. There is no security to the software. Anytime the software can go down. So that's why we need to ensure that before going to the package, we need to make sure that the test reports should give all zeros. That is zero errors, zero vulnerabilities, zero duplicates, zero warnings, zero errors. So like that. So then only we are allowing to do the package. For such application, only we have more security and more sustainability will be there. And next, now the package is ready. Now we need to move that package into some environment where the application is running. That environment is called as runtime environment, and the process of moving this package into that runtime environment is called deployment. The process of moving that package into runtime environment is called deployment. So one of the major day-to-day jobs of DevOps engineer is deployments. Every day you are going to do some deployments. Now later other things nothing but so customers can access that application. Next, you are providing the continuous support to that application. For example, so now here the application is now delivered to the customer. Now what happened? The customer wants to add some services. The customer now want to add some services to the existing one. So then what happened? Again, so the developers who are writing the code, developers writing the code for that new services. And again, that is also in the ASCII format. And again, compilation we have to do, and testing we have to do, package we have to do, and again, deployment we need to do. And finally, this flow will be continuous. But if you observe here, this is a manual task, right? So developers, after writing the code, the rest of the services are manual tasks. That is compilation, testing, package, moving the package into deployment, runtime environment, so service. So all these are manual tasks. They're taking some time. For compilation, it is taking some time manually. When you speak with respect to manually, so it is taking some time. So, but DevOps means it is automation. It is complete automation. Whenever the customer wanted new services, developers are writing the code. Once the developers are writing the code, these steps should be automated. These steps should be automated. That means automatically compilation should be done. Automatically testing reports will be done. Automatically package will be deployed. So if the testing reports give 0 bugs, so then automatically package will be there. Then automatically the package moved to the runtime environment. So that is called deployments. And the application should be available automatically once the code is ready. So this the DevOps engineer should ensure that is continuous process. So the major agenda of DevOps is continuous automation. Automation is the task that is DevOps engineer should monitor. Okay. So now this is the flow that is there in the environment. So now we have seen, let us take Java language here. So as I said previously, so there are three types of editions in the Java. So Java standard edition. So if the developers are using this standard edition, they are writing the code with some small basic functionalities like JDBCs and some HTTP containers, HTML pages. So like that, only few applications which are run by using the standard edition. Okay, so the output of this Java standard edition is nothing but that is also artifact that is we call that is in the format of .jar file. That is .jar file. I'll explain once again what is meant by .jar file. And when the developers are using this Java to Enterprise Edition, so they can develop the code by using servlets, JSPs, and EJBs. So, and they can now the code that is developed in .var format. The code that is developed in the servlets, JSPs, and EJBs. So the final artifact is called .var. And for example, if the mobile applications developers are preparing a code, then that is called EAR. So .jar, .var, .ear. So these three are very, very important terms you need to understand here. So what is .jar? .jar means full form is Java archive. Java archive. So .var means it is web archive. So EAR means enterprise archive. So these are the three types of packages which are developed by using the Java language only. Single Java language, we can build three types of packages: .jar, .var, .ear. So here .ear is nothing but sum of .jar and .var. Okay, I'll explain again. So now here in the previous process, we are seeing that one term called runtime environment. We are seeing one term called runtime environment. Runtime environments. So what is runtime environment? So runtime environment, it is nothing but a platform. Runtime environment, it is nothing but a platform where the package or artifact that is moved. So where the code is executed. So actually here it is the package. So package is nothing but, okay, it is a collection. It is nothing. It is also called as artifact. Artifact is a collection of this byte code. Collection of byte code. For example, you are downloading VLC media player as I said previously. That is in the .exe format. So on what platform you are executing this VLC media player or .exe file? On what platform you are executing this file? On Windows platform you are executing this VLC media player, because .exe is nothing but it is only executed in the Windows operating system. So likewise, so we have to execute this package, we require one platform. That platform is nothing but Windows platform. So similarly for Java, we have three types of editions are there, and each and every edition will give a separate package. If it is a standard edition, it is giving .jar package. If it is enterprise edition, it is giving .var package. If it is mobile edition, it is giving .ear package. So all these are packages. .jar, .var, .ear, all three are packages only. So now we need to move these packages into runtime environments. We need to move these packages into runtime environments. So based on this movement, so we have three types of runtime environments are there. Runtime environments are three types. First one, web servers. Second one, partial app servers. Third one, app servers. So there are three types of runtime environments are there. So first one is web servers, partial app servers, and third one is app servers. So web servers. So it is web servers are having only one functionality. Is having only one functionality, which is nothing but HTTP container, which is having only one container, that is having HTTP container. Web servers are having only one functionality, that is nothing but HTTP container. So where HTTP container means it is executing only few applications like HTML pages, CSS. You can call CSS means cascade style sheets and images. In the software application, any whatever the application we are built, so that application image, so that is it is able to run. So that is the function of the web servers. So web servers are having only one functionality, that is it is having HTTP container. In the HTTP container, it is having only few operations. That is it is displaying only HTML pages, cascading style sheets, and images. Next, partial app server, second point. So this partial app servers means those are not web servers, not app servers. So it is having the features of both. Like, so it is these are used to run servlets as well as DSPs. Servlets as well as DSPs. So it is having, these are nothing but these are not web servers, they are not app servers. It is a partial app servers. These are only partial app servers, and it is having HTTP container, and web container, having both web container. So nothing but it is having few features, both the not fully web servers, not fully app servers. So these are having the two functionalities. like HTTP container and web container. So these are going to execute servlets and JSPs, nothing but codes, Java language codes only. And third one is app servers. So I think most of you know about the app servers, nothing but mobile applications for this. So these are having both HTTP container, web container. Third one is EJB container. As I said previously, right? So for jar file, for .var file, .ear file. So .ear is nothing but a collection of jar file and .var file. So web servers, which are used to execute HTML pages, CSS, and images. Special app servers are having HTTP container and web container. Two containers are there, and they can execute both these applications along with this servlets and JSPs also can be executed. And app servers. App servers are nothing but collection of both, all the above, web servers and partial app servers along with EJB container. So three things will be there here. So these are the three types of runtime environments. So only today, only we have this much of theory. So from tomorrow onwards, there is no theory. From day 2 onwards, we are completely working on the practicals itself. Okay, so hope you understand, right, until this part. Any doubts here? So here, for as a DevOps engineer, so no need to learn about the any language. That's the main advantage of DevOps course. No need to learn any code. No need to learn Java, Python, .NET. Coding language is not at all required. These are some basics only, basic stuff for understanding purpose. Here you need to understand mostly three types of packages you must understand, because in future you are going to work .jar and .var. So mostly 99% we are working on these two only. So .ear mostly not used. Okay, we are mostly working on .jar and .var only. And you need to understand this flow. So what are the steps? What are the steps? What we are doing and what is our role? What is our responsibilities? So what is monolithic service? What is microservice? You must aware of the differences between these two. And the flow. So what is the flow here? It is you must understand. And next, you need to understand the packages .jar, .var, like that. And you need to understand the types of runtime environments. We have three types of runtime environments: web servers, partial app servers, and app servers. So web servers are having only one functionality. It is having only one, that is HTTP container. So in which developers are writing the codes for HTML pages, cascade style sheets, and images. Only for few applications only web servers are useful. Next, partial app servers means it is a combination of web servers and that is HTTP container. That means it is doing the functionality of a web server along with the servlets and JSPs. And third one is app servers. It is a combination of web server and partial app server and app servers. It's a combination of three. So HTTP container, web container, and EJB container. The three containers, the combination is called app servers. So now, how we are executing the code? That means here in the previous flow, you understood. So the package we are going to prepare, that is artifact that is going to prepare, develop. So what the package or artifact that is in either .jar, either .var or .ear. Or in general, if you talk, so the package may be any of the language. If the developers are using Java language, then the artifact may be .jar or .var. If the developers are writing the code in .NET, then this package, this artifact will be in .NET itself. If the developers are preparing the code in Python language, then this package should be in the Python itself. Then the runtime environment also will be different. I'm explaining here the runtime environment for the Java language only. Okay, here the 3 editions in Java language, the 3 runtime environments for Java language only. If the language is changed, instead of Java, if they are writing the code in some other language, say .NET or Python, can we use same environment? No. We are not supposed to use the Java environment for deploying the .NET files or Python-based artifacts. Okay, so first we need to understand, so what are the different types of languages that developers can write the program. So here majorly the developers are which are writing the programs in Java, .NET and Angular.js. So these are the majorly. So these are the most of the developers which are writing the programs under the 3 environments, 3 languages: Java, .NET and Angular. Okay, so here for if the developers are writing the code in the Java language, so we need to do the package. That means we are getting either jar file or var file or EAR file. For that, we are using some tools. So how do we get the package? By using some tools. Okay, that tools are called build tools. The tools are called as build tools. By using the build tools, we are going to package the code. So if it is a Java language, so Ant, Maven, Gradle. So these are the, some more are there, but most of developers, which are most of companies are using these 3: Ant, Maven, and Gradle. And out of 3, so Maven is the preferable one. Easy to understand, handy. So we can easily work with the Maven here. So if you work with the Maven, so Ant and Gradle also very easy. Same process. So what is the function of build tools? Anybody? What is the function of the build tool? The function of build tool is to generate the package. The function of build tool is to generate the package. So now we are using Ant, Maven, Gradle, any one of the tool for Java package, Java artifacts. So now once the package is developed, so then we need to move the package into the runtime environment. If it is a Java language, so what is the runtime environment we can use? We can use any one of the runtime environment, either web servers or partial web servers or app servers. So before that, so what are the packages we are getting? So what are the packages we are getting? Here we are getting .jar, .ear, .var, and .ear. So 3 types of packages we are getting with Java language. And what is the runtime environment? For example, so see here, if it is a jar file, so Java is sufficient to run the code. Since here we need the runtime environment, right? So whatever the package you are prepared, that package you need to move into the runtime environment. Why we need to move the package into runtime environment? Why? That is nothing but deployment. Why you are doing a deployment? Because to run the application properly. To run the application properly, we need some platform. The platform is called runtime environment. Runtime environment is nothing but the platform where the application that is moved. The process is called deployment. So if it is a jar file, if it is a jar package, so Java language is sufficient. Java language is sufficient to run the jar file. If it is a var file, so we need Tomcat. Nothing but it is a web server. Tomcat web server that is required for deploying of .var files. And for .ear file, we have the runtime environments like WebSphere, WebLogic, Glassfish, etc. So still most of them are there, but the most we are not currently working with .ear. We are working with only .jar and .var. That's why. So to run the jar file, we require Java. Java is sufficient. If the Java is installed in your local system, then the jar files can be executed. So to execute the var files, to run the var files, we require one application called Tomcat. We require application called Tomcat. So here come to here the same thing for Java. For Java language, so we are using the build tools and nav and gradle. So by using any one of the tool, you are getting the packages either .jar or .var or EAR. So next runtime environment, as I said, I mentioned, right? So it is either Java or Tomcat or any one of the application like WebLogic or WebSphere or any other thing. Like that, we need for Java language. For example, if it is a .NET language, if the developers are writing the code in the .NET language, so then the build tool is MS Build. The build tool is MS Build. So for this, we are getting the package in the form of .NET format. That is the packages we are getting here. And the runtime environment, here it is IIS, IMS, like that. So these are the runtime environments we are using for the deployment of .NET based artifacts. IIS means information in, I think information interchange service, like that it is there. But most of the companies are which are preferring Java, so using Java or Tomcat like this. If it is a .NET means the build tool should be MS Build and the runtime environment is IIS or IMS. Anyone we can use. And next, if it is a Angular.js, so then the build tool is Node.js. Build tool is Node.js. So if you observe here, both Java and .NET. So these two are backend services. There are two types of services. One is backend service. Other one is front-end service. Front-end service nothing but UI. So backend services means the applications which are running the code in the background. So for backend services, generally Java or .NET or Python, that is also used for backend services. For front-end services or UI services, so the language that is used is Angular. Angular.js is the language that is used for developing the front-end services. So this is the different types of languages and different types of build tools, and what are different outcomes by using the build tools, and how we are moving that packages into the runtime environment. We have seen now. And next point here we need to understand here. So just previously I mentioned, right? So developers are writing the code, and later this part is DevOps engineers, and this process should be automated. This process should be automated. So based on this concept, so DevOps has 6 phases. 6 phases. First one is continuous development. Continuous development. Next, continuous testing. Third one is continuous development testing. Here, just go here. Continuous development. First, after developing, done by the developers, doing the testing. Next, we need to integrate the code. That means we need to build the package. Nothing but integration. Continuous integration. Next, continuous deployment. Next, continuous. Next, after deployment, we need to provide the service. Continuous monitor. We need to do the continuous monitoring and continuous delivery. So continuous delivery. And last one is continuous monitoring. You are doing continuously. You are doing it continuously means automating. You are doing the automation. Once the development is done, so continuous development means if the developer continuously working on the application as per the customer requirement. The customer want to add any application or add any feature to the existing application, existing service, then he's continuously working on that. After that one, so testing should be done, then package should be developed, and that package should be deployed, and that package, that application should be delivered to the customers, and that application should be monitored continuously by the DevOps engineer. So he continuously monitoring the applications where the application should not under go down. It should continuously run. It should continuously run. That is a major application of the major role of the DevOps engineer. So in interview, so definitely asking this question. So what are the different phases of DevOps engineer? So you should say all these 6 steps. So continuous development, continuous testing, continuous integration, continuous deployment, continuous delivery, and continuous monitoring. Hope all of you clear about these 6 points. Development means developer continuously working on the code as per the customer requirement. So the developer code should be tested by the developer as well as the testing team. Next, integration means we are doing the package. Once the testing is done, so then we are DevOps engineer can do the package. So once the package is ready, then we are doing the deployment. Once the deployment is done, so then we should reach the customer. That application should run continuously. And monitoring means the application should monitor continuously so that it should be served to all the customers depending on the load. So this is the main role of a DevOps. Main phase of DevOps. We can call phases also, 6 phases. So this is a very, very important question also. So in interviews, mostly they are asking, what is CI/CD? This is a very, very important question. The first basic question any interview can ask. So what is CI/CD? CI/CD means continuous integration, continuous deployment. Because these 2 tasks are done by the developers and testers, right? Development and testing. So these 2 tasks are done by the different teams, development team and testing team. So these are the roles of DevOps. So continuous integration, continuous deployment. So the very, very important question, continuous integration and continuous deployment. So that's why DevOps tools are also called as CI/CD tools. So DevOps tools are also called as CI/CD tools. Now, a simple analysis here, a small example here. For example, an application is prepared. Let us take e-commerce. Let us take a small service, shopping service like Amazon. Let us take a service. Now, initially, the service is prepared. So, keeping in view of say 100 customers, their client is thinking that only 100 customers they are visiting the application, this application. But during the festival season or any other sales season, what happened? So this number will be increased. So that means this 100 will become 1,000. So then what happened to this application? What happened to this application? If 100 customers are become 1,000 customers, so what happened to this application? The application will go down. It is not accessible to even a single person. Even a single person cannot able to access this application. So then what we need to do? So what is the next task we need to do? So that means initially we need to increase the capacity. That means the application should be accessed by 1,000 people. We need to increase the capacity. So how we increase the capacity? So by adding the servers, because Amazon it is nothing but application. That application is running a server called application server. So this server has only some limit, that is say 100 customers. Customer count is increased to 1,000. So what happened? So this application is go down. Then if the application is go down, so then it is not able to reach by a single customer even. So for that, what we need to do, what the company can do, so they are increasing the capacity of this application to reach 1,000 people. So then what happened? So they need to purchase. So they need to add a new machines. They need by adding new machines. But new hardware is required, right? So computers are required. Next, network switches are required. So routers are required. So like that, so many equipment is required. Physical equipment that is required. Physical equipment that is required to reach the service to 1,000 customers. But since here you need to keep 2 points in mind. One is 1 point. What is the first point? Here to purchase all these is taking time. Purchasing as well as installation. For both purchase as well as installation, it is taking time and also costly. Next, second point is important point. Since these 1,000 customers are not daily visiting the application, they are visiting only during the peak hours, say festival times, or when the company released the offer at the time only they are visiting this. But what happened to the rest of time? In the rest of time, only 100 to 200 or 300 the customers which are visiting this website. So during that time, so these servers are not required, right? These additional equipment that is you are purchased during that time, that is not required. Only in the peak time only these new servers are required. But during the normal hours, these are not required. Means, so these are not operating under normal times. Normal seasons, they are not operating. So that is, we need to keep the machines as ideal state. So when the machines are in ideal state, that to the physical machines, so we know that physical machines when are running an ideal state, so which are not having durability is not there. So that those are not running properly in future. So for that, so keeping these 2 points in mind, so most of the companies are preferring so cloud. Most are going for the cloud. So what is cloud? So cloud means it is nothing but a virtual server. Cloud is having virtual servers. That means the customer can no need to purchase any physical machines. Customer no need to purchase any physical machines. No need to keep it with him. It's simply in the cloud itself. Whenever the customer wants, they are in the picture. Simply you can call they are prepaid. They are called prepaid. Whenever the customer required, they are coming to picture. If they don't want, so they are not used. That means it is not related to the customer is no need to purchase any hardware. The customer no need to purchase any hardware. But hardware is there means it is there. Hardware is there and that is maintained by the cloud providers. That hardware is maintained by the cloud providers. So these cloud providers maintain the physical servers. These maintain the physical servers. Cloud maintainers, cloud providers will maintain the physical servers and they will supply to the customer as per their requirement. Therefore, the customers are no need to purchase any physical hardware for their applications running. So that's why the cost is reduced. The customers can think only about their applications. If the customers are purchasing the hardware by their own, so they need to think about a lot of things. So they need to think about the cost. They need to think about the working of the equipments. They need to think about the security of that equipment, and they need to think about the application. And in so many aspects, the customer can think to run the application properly. But when the customer is taken the service from the cloud providers, no need to think about all the issues. They need to think about only one issue about their application. They need to think about the application because all the features, whatever the features, that is physical machines that is given, that is supplied by the cloud providers. Next, uh, security that is also given by the cloud providers. So depending on the load, the cloud providers can provide that. So that is called virtualization. That process also provided by the cloud providers. So lot of advantages are there when the customer is going for the cloud providers. That's why most of the software companies are looking into the cloud providers nowadays. So generally in the market, so there are 4 types of cloud providers are available. Cloud computing providers or simply cloud providers. The first one is Amazon is giving AWS, Amazon Web Services. Amazon Web Services. Next, second one, Microsoft. So he's providing with the name Azure. And third one, Google. So he's providing GCP. The name is GCP, called as Google Cloud Platform. And one more company, IBM. So this is providing blue chip. So Bluemix. These are the 4 cloud providers who are providing the cloud services. Amazon, that is AWS, Microsoft, Azure, Google Cloud Platform, IBM, Bluemix. So most of the companies are using Amazon, that is AWS, and Azure, and three companies which are using GCP. So these are the three major services, and out of three also most of the companies AWS and Azure. So recently AWS and Azure, so both are so very trendy. So most of the companies are which are preferring AWS and Azure due to their functionalities, inbuilt functionalities in it. Okay, so for our DevOps class, I'm using AWS. I'm explaining the DevOps tutorial from tomorrow onwards on AWS, Amazon Web Services. So any cloud computing providers are providing three types of services. All cloud providers are majorly providing three types of services. That is, first one, IaaS, PaaS, SaaS. This is also a very important question. So what are the services which are provided by the cloud providers? It may be Amazon, AWS, Azure, GCP, Bluemix, whatever the platform it is. So all these should provide these three services. So what is the first one? IaaS means infrastructure as a service. Infrastructure as a service. Second one, PaaS. PaaS means platform as a service. Third one, software as a service. Any cloud computing providers can assure these three services: IaaS, PaaS, SaaS. IaaS means infrastructure as a service. That means any cloud provider should give the infrastructure as a service. As I mentioned before, right? So if the customer instead of installing the physical servers at the customer end, so this AWS can provide infrastructure to the customer itself, in the virtual format. Therefore, the customer are no need to keep the physical machines at his hand. He simply go and purchase whatever the amount, what is the size of machine he required, what is the size of memory, what is the cost. So he can choose. As per that, he can purchase infrastructure as a service. Next, platform as a service. So platform is what is the type of platform he can purchase that one. So next, software. So instead of developing the package each and every time, inbuilt softwares are there. Inbuilt softwares are there. So those softwares can be supplied by these cloud providers. These are the three important services that are provided by any cloud. Any cloud provided these three types of services. So this is about some basics of DevOps. So now I'm quickly go through what is the content, what is the syllabus. So the syllabus. So see this image. So this is the image you can see here. So whatever I said. So here the code. The first developers are who are first one is planning. That means when the customer approach a company, so then the release manager, the project manager will do the plan, and then that plan is given to the project manager, and that one then the code we are building. So that code is developed by the developers, and then we are building the code. And this build, after the building, so we are giving the testing team. So the testing team can test the package, and then we are doing the release. So after the release, we are doing the deployment. So after deployment, we are doing the operations, and then we are doing the monitoring. So once the monitoring is done, if anything is to be added, then it is a continuous process. It is a continuous process. So for code, I'll explain the tools tomorrow. Tomorrow onwards, I'll explain the tools. So these are only few tools. In the image you are seeing, these are only few tools. So like Git, Jira, Confluence. So these are not build tools. So Git also is not a build tool. So Maven, nothing but it is a build tool. So next, Selenium, Java, JUnit. So these two are used for testing purpose. And for release, so Jenkins we are using here. So for deployment, so we are using Docker, AWS we are using. For operations, Chef, Ansible, so Kubernetes we are using. For monitoring, so Nagios, so Splunk, Datadog. So next we have some other also there. So I explain the different types of tools which are used in each and every phase. Like coding section, what are the tools we are using? In build, what are the tools we are using? In testing. Likewise, in each and every phase, I'll explain the tools which are using in the DevOps role. And one last point here. So this is a complete syllabus of DevOps here. So starting here, demo class here. So from tomorrow onwards, I'm starting the AWS. So in the AWS, we need to create account. So actually for account creation and creation of PPC, these two will done in a single class. So no need of taking two classes here. It will be done in a single class. So next EC2 instance, and these services I'll explain at the end of these sessions. Next, tomorrow I'll explain how we are creating the AWS account creation and VPC creation also. And the day after tomorrow I'll start the EC2 instance. And after that, I'm going in the Linux commands. I'm explaining what are the Linux commands which are useful for DevOps purpose, not in detail how much it is relevant for DevOps role. So till that one, I'm explaining the Linux commands. So after that, GitHub I'm explaining. So next Maven, the build tool. So next Apache and Nginx. So these two are nothing but web servers only. So Tomcat as a web server. So Jenkins, so Ansible, so Jenkins is nothing but it is a heart of DevOps. It is nothing but heart of DevOps. So next Ansible, next Docker, Kubernetes. So these two are very, very important tools. So in nowadays, most of the interview questions which are asking on the Kubernetes, but most of the companies which are looking for Kubernetes expertise. Kubernetes is a main tool you need to learn. Okay. So when compared to all the tools, so Kubernetes is the main tool in most of the interviews they're asking the questions on this tool. But so the interviewers are not only focusing on the Kubernetes, they're also focusing on this one because Kubernetes is recently it is coming to focus, and most of the companies are migrating into the Kubernetes environment. So, but before that, you need to learn about all the tools. All the tools are must and should you need to learn. And next, Helm, it is related to Kubernetes only, and Terraform. So Kubernetes and Terraform. So most of the companies asking the interview questions on these two, Kubernetes and Terraform. So these two are very, very important tools among all the DevOps tools. And remaining tools are also very important. And so whatever the tasks we are doing by using this process, we can do by using a single Kubernetes. By using the same thing by using Kubernetes also we can do. But in interviews, they're asking the questions on these topics also, because most of the companies are still depending on this one. So before going to the Kubernetes, so Jenkins play key role. So Jenkins is very, very important. That's why. So if you want to survive as a DevOps engineer, you must know about Jenkins, Kubernetes, Docker, and Terraform. So these things are very, very important. These four are very, very important. After completion of this part, I will explain the AWS services like Amazon Machine Image, Load Balancer, Auto Scaling. So these two are very, very important. I just before said, right? So auto scaling. Auto scaling means depending on the requirement. Depending on the requirement, the number of servers should up and running. As I said in the example, so customers are suddenly increased on the application. Then what happened? So if you want to purchase a physical machine installation, and so till that the customers won't wait, right? So on the fraction of movements, the server should go up depending on the demand. The servers should go up virtually, and if the demand is decreased, the server should go down. It reduces the cost. So that is called auto scaling. That is called auto scaling. Auto scaling means automatically scaling up or automatically scaling down. That means the number of servers should be automatically increased or automatically decreased based on the load. Okay. Next, load balancer. That is also very important feature for Amazon. So next, S3 bucket, so Glacier, IAM, so CloudFormation. So I'll explain all the tools related to AWS. All these are belong to the AWS part. And the DevOps tools are start from this part, Apache Nginx. So from this, DevOps tools will start. So tomorrow I'll explain about how to create the AWS account creation, and I'll explain how to create VPC. So hope I think you understand clearly about the basics of DevOps. If you have any doubts, you can ask me. Any doubt?